Hi, I'm Alan Ross. I'm the managing editor of APC Media's publications, Transformer Technology, Power Systems Technology, and Women in Power Systems. We're here at the IEEE PES&T conference in Anaheim in 2024, the 60th anniversary. These interviews are with thought leaders to be able to bring the best of the marketplace to you. This is the first guest of the day, Joshua Yun. Joshua, tell me a little bit about your background. How did you get in the power industry? And why? Okay.
I'm actually an electrical engineer.
Okay.
Graduated from Georgia Tech.
Georgia Tech, mechanical.
Mechanical?
Yeah, right.
Yeah, very good, very good. So at that time, I guess, senior year, I guess, everybody was going into new technology called cellular technology, right? But it really wasn't for me. I wanted to do something that I can really touch, feel. I want to see explosion type of thing. So that's how I got into power.
Okay.
So since then, I graduated and then worked for actually EPC company. They're doing medium voltage, high voltage power equipment.
Yeah.
So I started my career as an electrical engineer, designing substations, electrical infrastructure for large steel mills, paper mills. And then spent about 6.5 years actually commissioning a lot of these equipment out in the field. So that's how I got into power industry. And then since then I moved on to on the commercial role. They did a P&L responsibility for several companies, and then I got into sales and marketing.
Okay.
So overall, I've been in electrical industry this is my 33 years into electrical industry.
Being in sales and marketing, having field experience, having design experience, that's got to help you tremendously. There's a credibility issue there, right?
Absolutely. So I gained tremendous amount of experience actually doing the designing and commissioning part.
Right.
Granted that a lot of the technology has evolved quite a bit since then, but at least I know where a lot of this equipment being used and how they apply. So that helps me tremendously. And then just like you said, credibility-wise, it helps us, talking to many of our clients.
So the other thing, Georgia Tech, we all know, this, has a nuclear reactor. Not many people know that.
Right.
Did you get to, I never got to see it. Did you get to see it?
No, it was one of those things that it's there, but
you're not allowed
to. No, you're not allowed to go be anywhere near.
As a matter of fact, it's like, there's a nuclear reactor in downtown Atlanta. Most people don't realize that anyway. That's why Georgia Tech graduates rule the world. Tell me, so you've done that. You've been in the industry long enough to have seen a great deal of change. Even though the industry has been kind of stagnant for decades, all of a sudden it's like a hockey stick of change. Decentralization, digitalization, decarbonization, wind, solar, all of that's happening. Talk to me a little bit about where you think we are as an industry.
That's a very interesting point. I can probably COVID. You can. Everybody was saying pre-COVID and post-COVID.
All right.
So pretty much that's the turning point. And right now, post-COVID, there was a lot of pent-up demand from a market perspective. A lot of projects were put on hold for various reasons, funding issues and geopolitical, and then also just the COVID itself. So when the COVID subsided, then everything basically came loose, right? Just everything was released. So we saw this big tsunami. I call it perfect storm. I have never seen. I've been in the industry for 3 decades, and I've never seen a market dynamic that I'm seeing today.
Right.
Pretty much every market segment that I can think of is just exploding.
Yeah.
Data centers, oil and gas, LNG, renewable, Bitcoin mining, lithium batteries, semiconductors. I mean, every market segment. And then fundamentally though, everything needs to be powered, generated, and transmitted by utilities. So utilities are also having a hard time keeping up with the demands.
Right.
That's basically where I see big demand spike. This demand coming from pretty much all market segment now at this point.
And some of the segments we would not have thought about pre-COVID, like data centers. There was some geopolitical things about we're going to have the data centers here. We're not going to have them in other countries, and it was not something that we really thought that much about. We did think about wind and solar. But even battery storage, there's a new demand for power for battery storage, which is crazy. I mean, it is a great time to be in the transformer market.
That's correct. Actually, on my way here, TSA, how you go through TSA check, right? Used to be just driver's license, and then there you go. But now every checkpoint has now capturing your face
Yeah.
recognition. So they're actually collecting face images from every traveler. So eventually they're going to use that as a boarding pass. So imagine all that needs to go into cloud.
Yeah.
So that needs to be stored.
Stored, right.
So every time you take a picture from your iPhone, again, that's driving demand for data centers.
Yeah.
So from a transform perspective, it really doesn't matter if it is a building is a data center or oil and gas, LNG, or it could be a government building, or it could be a Walmart.
Right.
Doesn't matter what it is, as long as that facility requires electricity, needs transformers.
Right.
Whether the question is who's buying the transformer, is that utility or is that the end customer? So you're absolutely right. Right now it's unprecedented demand for transformers.
Right.
And that's creating a huge also constraint and stress into the marketplace as well.
So, and that's, we know because the two biggest issues that transformer manufacturers have been facing, one was flat demand. Now this is spiking, right? So you got an engineering issue about it. You got to engineer a lot of different types of transformers. Another one is we had supply chain issues that are still not over because demand, you start to do it. And the third one is they're still made by hand. You need a lot of labor in order to be able to do that. How is Virginia Transformer? Well, first let me go there. Your role at Virginia Transformers, you're the head of sales and marketing for Virginia Transformer.
That is correct.
So my credibility for you is the fact that you've been out of the field buying them, specifying them, so you know how to sell them. So approaching that, how do you handle the labor, the supply chain issues, and the just incredible engineering demands that, because the utilities, data centers, everybody is expecting it to be specific for me. It's almost like every transformer is made uniquely, right?
Right.
It's not like assembly lines of cars.
No,
How do
not
you
at
handle all those three? That's another perfect storm for you.
Absolutely. So I'm actually a senior vice president of sales and marketing for Virginia Transformer. To answer your question, this challenge is not unique to our company, but as overall transformer industry, right? So like I said, all of a sudden this big tsunami of demand become available, and then everybody now faced with issue still hasn't got over supply chain issue. We're still dealing with almost like every month there's a new flavor of the day. There's insulation shortages. All of a sudden when you got over it, there's a bushing issue. So it's just one after the other. So to answer your question, how I guess our company at least kind of try to handle that and then overcame some of those challenges was the CEO and also the owner of our company kind of saw that what was going to happen from demand perspective.
Prabhat Jain.
Yeah, so his name is Mr. Prabhat Jain.
Yeah.
So it's basically a visionary. So when he saw that, when everybody else were laying people off and all that, he actually invested. So he actually launched a brand new facility, ground up, greenfield operation in Chihuahua in preparation for this tsunami to come. So perfect timing. And then, we as a company did struggle in the beginning, again, with supply chain and labor, especially labor, finding a good labor, because these are handmade product. It's not like automation, you can just put it on the automation line. So finding right talent, right labor, took a lot of effort.
Yeah.
So, but just giving you an idea, last year alone, year 2023, our company hired 1,000 direct laborers.
Wow.
1,000 direct labor.
Wow.
Right? Granted, we did lose some people. We had turnover, but now we have in process in place, onboarding process and training, all of that in play to kind of maintain, lower the turnover. So we're in good shape right now. So first of all, labor was a major issue. So we were able to overcome that. And then the second thing was material.
Yeah.
Right? I mean, right now, it used to be good old days. If you have 3 suppliers for a major, let's just say, a product, let's just say core steel, conductor, you're doing good.
Yeah.
Now, reality is no one supplier can provide all the requirement that we have. So we ended up tapping 10, 12, 15 suppliers just to be able to get enough material. So what Mr. Prabhat Jain did is he went out and stocked up this critical long lead item. We're holding on to about $20 million worth of critical raw material.
Okay.
And then it takes up a lot of space, so we actually took out basically storage facility near within 5-10 mile distance from each of the plants. So
Right.
we are actually holding on to about 20 million, and as we deplete them, we backfill those.
Right.
And the third thing you mentioned about, obstacle that we needed to overcome was design, engineering, resources. So, at the end of the day, these are custom built, highly sophisticated product, and then it's driven by specification.
Yeah.
So you can't just take, and spit out a standard. There's no such thing as standard design. So one thing that helped us is we have, because we've been in industry and business for 52 years. We're established in 1971. So because of 5 decades, we've been doing nothing but transformer. We have what they call done design,
Right.
reference design. So we have over 20,000 reference design that we can use it as a base to complete the design. So we don't have to start from scratch every time.
Yeah.
So that helps tremendously. But also to ensure that we have quality, product. We're building quality product. I don't know if you know this or not, but 1 out of every 4 direct employee building our transformer in the plant are degree engineers.
What? Really? Yeah.
1 out of 4.
Yeah, the Prob told me that. Yeah.
Right? So right now we have about roughly 800 employees, direct, degree engineers. 500 of them are actually working day to day, side by side with our direct laborers,
Okay.
factory associates, right? And then 300 of them are dedicated for engineering. And then same thing with because it's highly technical product, even sales department. And I have a huge sales team right now. 90% of my staff are engineer, either electrical engineer or mechanical engineer, because we call ourselves engineering company that design and build transformers.
Oh, that's good. I like that.
That's how we describe ourselves.
You're not a transformer manufacturer.
Right. So, and
engineer.
another thing that we were able to overcome was lead time, right? Because right now, I don't know if
That's
you know
a big
this,
issue. Yeah.
know this or not. Right now, typical 100 MVA transformer, average lead time is 3 years.
Yep.
Think about it. Highly custom designed transformer, and if it, for whatever reason, fails, you have no spare. You have to wait 3 years to replace.
Yeah.
So if you look at a typical data center or hospital, if that transformer somehow fails,
Yeah.
then what?
Yeah.
What do? So number one, quite honestly, the number one obstacle or the issue that industry faces is how do we offer shorter lead time?
Yeah.
But again, think about what allows us to offer short lead time. You got to have, first of all, capacity.
Right.
So because now we were able to bring in additional plants, and now every plant's on third shift, and things like that, we were able to make improvements, expand the capacity. So right now we're sitting at 80,000 MVA capacity. So 80,000 MVA capacity makes us one of the largest transformer manufacturer in North America. So with that, couple that with adequate, sufficient amount of labor. We have design library that can support, influx of design requests, along with technical expertise, and then material, $20 million worth of material. So that's all a combination that allows us to offer the shortest lead time in the industry at this point.
It's the perfect storm of good things.
That is
You're
correct.
bringing things
Unprecedented.
together.
I mean, I've
Yeah.
never seen, like I said, this is the first time I'm seeing from market dynamic perspective.
Right. So when you think about the market, I'm a customer, okay? And you approach me, what can I do? What can we expect the market to do to help alleviate some of those stresses? Because sometimes in the market, it's like, hey, here's my bid. Somebody meet my bid. Mm-hmm. That's not going to work anymore, because you may get a bid, but it may be 3 or 4 years out.
Right.
Right now, I need it now. So how do I help you if I'm a customer in the marketplace?
Yeah, so that's a fine balance, because everything starts with specification, and then there's a reason how that specification put together. In a perfect world, customers should demand, and I expect customer to continue to say, I want transformer made, full compliance to the spec. But there may be some item in there that will not allow us to provide short lead time. There may be a few feature here and there. So this is where we also come in, and we look at the specification during RFQ phase. We let them know, here's a proposal based upon 100% compliance to spec, and this is the price and lead time.
Right.
But if you allow us to deviate, take exception to some of these, lead time goes from 120 weeks to 80 weeks.
Okay, good.
So we can also offer that as an alternate.
Yeah.
Right? So this is something that customer can consider. Another thing right now is bigger the transformer gets, the more scarce the capacity and lead time. So instead of buying 300 MVA transformer, perhaps potentially I'll think about perhaps buy 250 MVA transformer.
Right.
That would also may cost a little bit more, but also increase reliability.
Oh, yeah.
Because you have redundancy.
Yeah.
One 300 MVA transformer fail, you lost the whole load,
Right.
whole facility. But if 150 MVA fails, you just lost 50%. So that's another kind of thing that as a customer can consider as well.
That's interesting because that's how data centers operate. They operate on the principle their reliability, 5.9 reliability, comes from redundancy.
Right.
Right. And that's a great idea because nobody really runs the transformer at above rating. So if they're, let's just say, 60, 70% load on a 300 MVA, and you get two 150 MVAs, you can almost replace all of that load with just one. Now you're going to run it above rating for a while, but you can keep things running. And with relays and everything now, they can route around it. That's excellent. I know one of the biggest things, the bigger problems, I'm co-chair of an organization called Safety and Reliability Association. We're a not-for-profit in the area of industrial and commercial. So you mentioned hospitals, data centers, things like that. Steel mills, paper factories, anybody that uses a lot of power. They seem to be the back end of the market. Utilities thought about this and they started buying up slots, right? A lot of the people, because their procurement system was so backward, because they're thinking of procuring all kinds of raw materials for what they make, they weren't thinking about procuring transformers. So now they say, we got to get transformers. And they're at the back end of it. How do you, because you all support that market pretty well, what do you say to them, the people that run paper companies and factories, all of them running at capacity? In the mechanical engineering world, capacity is 85%, right? Everybody's running 92 to 97%. We're way over capacity. They can't shut down. So a transformer failure can be catastrophic financially. So what do you say to me as one of those companies, not the commercial side, because they're building capacity, the people that are running flat out, how can I help you get what I need?
Yeah, that's a very good question. One of the benefits having multiple plants, we have 6 plants in North America, 4 of them in US and 2 of them in Mexico.
Right.
So, and then we purposely built in overlaps.
Okay.
Overlap meaning, for example, 30 MVA transformer. Right now, they could be built at 3 different locations.
Okay.
So, and then each plant has their own sweet spot, so they kind of cater toward certain market segments. But at the same time, because we can run same design regardless which plant, right? And then pretty much everybody's on the same manufacturing processes and quality system and everything else. So it really doesn't matter for us taking, even if it was duplicate order that we received a year ago from one plant, if that plant is full, right? And then there's a third plant that happened to be having open slot, we can actually put that into schedule, that particular new order into the different plant, third plant. So that's one way that we kind of mitigating that situation. But at the end of the day, right now, what probably the best thing anybody could do at this point is plan ahead. So right now, as you mentioned, utilities are a little ahead at this point. So they're actually planning their project up to 2030. Okay. We have requests coming in, hey, what can you do about 2029, 2030 up to this point? Right. But I understand commercial industrial, a lot of the clients like customers like this, they just don't have the bandwidth or horizon. So I strongly recommend, if you know for sure you have project, plan, right? But if you don't even know what it is that you need, but at least get an idea, if size-wise, voltage-wise, talk to us. Yeah. There's a lot of things we could do. We could work with the customer, give them some offer as to what's available. You can either buy slot, pre-advance, lock it in, or we can actually help them at least eliminate some of the upfront work right, ahead of time. So from anything we could do, so the best thing to do is just contact us, and then we can sit down case by case and then work with them to kind of mitigate whatever problem, issue that they're facing.
I'll tell my members that. Actually, we're going to post this on our website for our members to say, you need to be thinking about your power needs down the road, because none of you are, you know.
Yeah, because people may not realize the situation, right?
Exactly.
So, you know, it's not everybody's just, you know, ignoring it. It's just not aware of the situation.
Last question, IEEE PES, we are doing a special issue in August where we're taking this one question I'm asking you, and then we're going to take a lot of answers that we get. Some are the advisory board people, but you've been a member of IEEE, I assume, since you got out, probably as a student, right? Most people did that now. Talk about the value of IEEE to the industry.
Yeah, I've been in, just like you said, I've been in member since I was in college, so, you know, 3 decades. But actively got involved when I got into transformer industry, so about 25, 26 years now. So I am actually a member, active member of IEEE Transformer Committee.
Yeah.
Right, so it's part of a PES society, and then so we meet. There's about 250 of us. We meet twice a year, spring and fall, and then so it is a very unique organization where, you know, people from different background. It could be manufacturers, it could be a consultant. Members comprise of also intellects. So there are professors, okay, you know, and then government agencies, as well as end users, utilities, and big users of the transformer. So we get together, and then we don't talk about commercial. You know, we're strictly forbidden. So we put down all the differences that we may have, and then strictly work toward creating standards and guides that could help the whole industry, betterment of the industry. So it's a very unique, very good organization that I'm proud to be part of. And then work that we do, although we're sponsored by the company, things like that, but we're so busy during the week. So, you know, all the work that's, you know, standard creation, standard edits, and everything else, we do it during our personal time, weekends, nights. So, you know, really there should be appreciation. I mean, I have a huge appreciation for everybody who's involved in creating and updating these standards. And then this standard, what beauty of these standards those bring to the table is it basically become a foundation, call it a rule or a building block, how everybody should design, build, test, and then maintain, and then repair transformer out in the field. So it basically levels the playing field. So, and then also tackles some of the emerging technology that's coming on board. It is very difficult for us to tackle that as an individual company. For example, reverse power flow. Right. So if you think about it, battery energy storage system, power, you know, goes both ways. Traditionally, transformer reverse flow one way. Now, it charges but also releases. So now try to come up with standard. Okay, that's one of the things that IEEE Transformer Committee is doing, is coming up with a standard for that. What are the do's and don'ts? And then also guides as to how do you handle something like this. So, and overall, a tremendous value to the industry that IEEE, the organization is bringing. Because without that, it'd be very challenging for individual company to come up with their own versions. Okay? So I think it's tremendous help, not only to the end user, but also the manufacturers, and everybody's involved.
That's excellent. Joshua, thank you so much for joining. I appreciate it.
Yeah, I really appreciate it.